Welcome to this new video from Guidance Education channel. In this video, we will be discussing hybridization. We are continuing class 11 chemistry chapter 4, chemical bonding and molecular structure. I am Anandavalli. I welcome you all to this new video from Guidance Education channel. In this video, we will do the concept of hybridization to explain shape of molecules. We have already seen that according to valence bond theory, a covalent bond is formed by the overlapping of atomic orbitals. Bond formation in diatomic molecules with single bond is easily explained by this concept. We have already seen a few examples. In the case of polyatomic molecules with single, double or triple bonds, formation of a bond, that is linkage, becomes more complex. The molecule may be homonuclear or heteronuclear. What is the meaning of homonuclear? That is atoms of the same element. Heteronuclear means atoms of different elements. The complexity of linkage in polyatomic molecules is because we have to discuss the shape of molecules as well. In the case of diatomic molecules, there are only two atoms and the shape of the molecule does not become a problem. They are all linear molecules. In order to explain this structure, valence bond theory uses an additional concept called hybridization. What is hybridization in chemistry? To understand this, we have to recall what we mean by orbital. We have already discussed orbital. If you have any doubt, please visit my channel and see the playlist named Structure of Atoms. Coming to concept of hybridization. This concept was first introduced by Pauling. Hybridization is the mixing of near energy level orbitals of the central atom of the molecule to form a new set of orbitals of same energy level. Orbitals of the central atom that mix have approximately the same energy, but the new set of orbitals formed will have the same energy level. Say for example, take the case of the molecule methane, CH4. The central atom is carbon. There will be 4 hydrogen atoms around the carbon atom. As per the representation that I have shown here, that is this representation, the bond angle between two adjacent bonds is 90 degrees, but it is not the case. These bonds have directional property, so that has to be explained. This molecule CH4, that is methane, is tetrahedral in shape. That is the structure of the molecule. Linkage is by overlapping. Of course, the various orbitals in the valence shell of this carbon atom mix up. They have almost the same energy. They mix up and give rise to a new set of orbitals and they have the same energy level. The orbitals that are formed in this manner are called hybrid orbitals. As per this concept, it is the hybrid orbitals that take part in bond formation. We will continue. We will see the features of hybrid orbitals. The first feature is that the number of hybrid orbitals formed is equal to the number of orbitals taking part in hybridization. That is, if two orbitals of the valence shell of the central atom get hybridized, then the number of hybrid orbitals formed will be equal to 2. If 3 orbitals take part in hybridization, then the number of hybrid orbitals formed also will be equal to 3. Next one, they have the same energy level. That is, the energy of the hybrid orbitals will be the same. Third one, they form more stable bonds. That is, the bonds formed by hybrid orbitals will be more stable. Fourth one, these orbitals have specific directional property in order to minimize repulsion. We have already seen that the attractive forces between the atoms participating in bond formation should be more than the repulsive forces. So, in order to minimize repulsion, these orbitals have specific directional property so that it becomes easy for formation of bond. Now let us discuss the conditions for hybridization. That is, when and under what situations does hybridization take place. First condition is that the orbitals should belong to the same valence shell. Valence shell is the outermost shell of an atom. Orbitals taking part in hybridization should have almost equal energy levels. Half-filled or fully filled orbitals can undergo hybridization. An orbital, we have seen, can hold a maximum of 2 electrons having opposite spins. Half-filled or even fully filled orbitals can undergo hybridization. Promotion of electrons is not essential before hybridization. What does it mean? Take the example of carbon. We have seen carbon is a central atom in methane. Carbon atomic number 6. Electronic configuration is 1s2, 2s2, 2p2. 2p2 means 2px1, 2py1. These 2s2 and 2p2 belong to the valence shell. These orbitals will be hybridizing. Carbon requires 4 single electrons for forming these 4 bonds. How is it attained? P orbital has 3 possible directions represented as x, y and z. Here you find the px has 1 electron, 2py has 1 electron, 2pz is empty. The fourth point suggests that it is not necessary for 1 electron from 2s2 to get shifted to 2pz before hybridization. Even without that, these 3 orbitals 2px, 2py, 2pz and this 2s can undergo hybridization, resulting in formation of 4 hybrid orbitals. When 4 hybrid orbitals are formed, these orbitals will have directional property and they will be arranged at an angle of approximately 109 degrees. And each of these orbitals will have 1 electron each and they will overlap with the outermost orbital of each hydrogen atom, which has only 1 electron, and the spin of the electron will be opposite to that of the electron present in each hybrid orbital of the carbon atom. It is the central atom. Now, with an angle of 109 degrees, the molecule will have tetrahedral shape. I hope it is clear. There are different types of hybridizations based on which orbitals take part in hybridization. We will discuss that in the next video. I hope you are benefited by this video. If you think it is useful, do like the video, share the video with your friends and also leave your feedbacks as comments. If you are watching without subscribing my channel, do subscribe it now and support me. Thank you very much. We will meet in the next video with the next important topic. Till then, bye. Take care.